We use the architectural metaphor of the museum and sequences of rooms and floors to help organize our learning modules and to help the user navigate through them. The first exhibit is an interactive sculpture designed to introduce users to one of the techniques used throughout the museum, representing abstract parameters of color by height. First, we see these cylinders arranged by height according to their hue. Now by value. When a researcher stretches a cylinder upward, it becomes lighter. Downward becomes darker. The white cubes represent the positions of the user's hands in the virtual world. Here is a Vermeer painting called The View of Delft. Vermeer is a favorite painter of computer graphics people because of the close attention he pays to lighting detail in his images. We press the button to bring a height field of the painting onto our interactive table. Lighter parts of the image are higher peaks and darker areas are valleys. This corresponds to language used by artists describing light areas as physically lighter and dark ones as heavier. By pinching the thumb and forefinger of his glove, the user is able to interactively modify the height field. Here we lighten the sky, changing the weather and hence mood of Vermeer's image. The sculpture and Vermeer experiments dealt with properties of a single color. The second floor of the museum has experiments relating to groups of color. We are going directly to the third floor, however, where we can study color spaces. First, we see an HSV cylinder. Disks cause multicolored snow to fall through the space. Each disk is colored according to its coordinates in the space. This and other techniques aim to reveal the 3D nature of these solid color spaces without using transparency, which would distort the colors. Here we can compare the properties of several color spaces. The HSV cylinder has a nice geometry and shows the lightest and darkest colors on its top and bottom. Fully bright, fully saturated colors desaturate to white, which is a nice property for building color pickers in graphics programs. The RGB cube plots colors along red, green, and blue axes, the colors of the phosphors of the computer screen, and is thus very useful for computer graphics programming. The final space is Munsell again. This type of space is called perceptually based. A perceptually based space is one determined by users' perception of change in hue, saturation, and value. The perceived difference between a color and its neighbors is the same in any direction. To understand this better, let's bring up a cutting plane based on perceived differences in color. In Munsell space, this shape is a flat plane. In RGB space, we can see that it looks a bit bent, like a Pringle. In HSV space, we can now see that the plane is tipping and folding in extreme ways. This means that when you move a value slider in your favorite graphics program, you are really changing other parameters as well, such as hue and saturation.